Alright, we're going to review some problems from your handout on drawing and naming cis and trans isomers of alkenes. Alright, in this problem we are told we have an alkene that is 4 carbons long, hence the buttes and the ene. I'm going to go ahead and start with this double bond because I see that we have an isomer of it. So here's my double bond. This is carbon 2 and carbon 3. So I know I'm going to have another carbon on either side of those to create my butene. I am also told that this is a trans isomer. So that means that if I were to draw a line through the double bond, I would need to have one group on one side of the double bond and a group across from it on the other side of the double bond. So let's go ahead and erase that. There's that line. And I'm going to go ahead and draw my other carbon. There's nothing coming off of that one, but I do have a chlorine coming off of my second carbon, which is right here, and a chlorine coming off of my third carbon. Now I have to figure out, am I going to put the carbon going down or going up? Remember, because this is trans, I have to put it going down so it's across that double bond, and it's in the trans isomer. So I'm going to go ahead and put my final carbon. So now I have 1, 2, 3, and 4 carbons, so butene. Okay, the double bond is at the second carbon. I have my chlorine coming off of my second carbon as well as my third carbon. Notice that they're trans to each other. And I'm going to erase that red line. So you should come up with the trans isomer for that. Alright, in this problem we have the hexene, which is a 6 carbon molecule, and it has a double bond, and according to the name we're told the double bond is at the third carbon. So I'm going to start off, there's nothing else on here, so I'm just going to start by writing my first 2 carbons. Because this is cis, I'm going to make sure that I draw my line going down for my double bond. And cis means that they're on the same side. So if I were to draw a line through that, my next group should be up here as well. So they're on the same side of that double bond. So I'm going to continue going up. So I have 1, 2, 3, 4 carbons already. This will be our 5th carbon and our 6th carbon. If you're having trouble knowing how many hydrogens to put in, or you're concerned about getting any of that out, don't worry about the hydrogens right away. Worry about those carbons. Place your double bond and draw what you're looking at. So here we have the cis, and then I can always go back and fill in those hydrogens later. But worry about the main structure of carbon first. Alright, let's go ahead and number our carbons and figure out how long our chain is to get the parent chain. If I number from the left, it's 3 carbons before I get to the double bond. If I number from the right, it'll be 4 carbons. Since that takes precedence, I'm going to number from the left to give that double bond the lowest number carbon possible. Okay, so we have hept for 7, and it has a double bond, so I'm going to name it heptene. First thing I need to do is state what carbon that double bond's on, and that is on carbon 3. So we have a 3 heptene. As I look at that double bond and I draw my line, I notice that my chain is on opposite sides, or they're across the double bond from each other. So I do know that this is a trans molecule, and I'm going to hang on to that because that's going to have to go at the beginning, but I'm just going to note that. Now we can worry about our alkyl halides that are coming off. So I have a bromine coming off in both the 3 carbon position as well as the 4 carbon position. So I can name this 3,4 dibromo 3 heptene. And I'm going to come back. That trans needs to go in the front to tell me that my carbons are across the double bond from each other. They're in the trans isomer. So my final name is the trans 3,4 dibromo 3 heptene.